So let's go now and jump into a theoretical and empirical models that will help us understand what is the relationship between the explanatory variables and the dependent variables. We are going to use a discrete choice model by McFadden in 2001 that is based upon the random utility maximization model of Marshak in 1959. And in this model, what we do is we characterize the utility that an individual I obtains from choosing to buy or not to buy. And we characterize also the choice of the individual with a dichotomous variable 0, 1, and that makes it important. That is the dependent variable, and that dependent variable is going to be 0 or 1 depending on what are the values that make an individual buy or not buy. So, and that those will be in general both the characteristics of the goods and services that they may buy and also of the individual characteristics. Continuing with the theoretical and empirical models, it will be useful to write a utility in terms of betas times z sub I plus epsilon sub I, where the sub I subscript refers to individual. So this will go from 1 to 46 million, and then in this particular case we would use the sample instead of the whole population because we don't observe the whole population, and in the sample we would say that the zi is a vector of observed variables relating to the individual I, and this vector depends on attributes of the alternative, perhaps interacted with attributes of the individual. So that would be something that is well established nowadays in the economics literature. And the idea is that we want to approximate the decision making process by the individuals using economics characteristics of the individual and also of the individual services or goods. Beta is the corresponding vector of coefficients of the observed variables, and they measure, they are unknown, and we want to know about them. They measure the strength of the effect of each of the explanatory variables on the dependent variable. And so those are the parameters of interest. And then we have an epsilon I, which is an error of the relationship and represents the impact of all unobserved factors that affect the person's choice. Then we apply logistic regression. We write a logistic regression model, which is similar to the linear regression model, but just with a non-linearity. And then what we do is concentrate on defining each of the three dependent variables that I have talked already about: cross-border e-commerce, cross-border e-commerce to the EU, and cross-border e-commerce to and from the rest of the world. And those would be binary values. Here in transparency number 12, I'm going to show which are the explanatory variables that we have used in the modeling. First, we are going to use gender, which we code as 1 if it is a male, 0 if it is a female. The age variable has several categories just to allow us for nonlinearities and also for easiness of interpretation. This is a typical way of using the variable age. The education is also in categories: primary or less, secondary, bachelor's degree, and master's of PhD. The nationality is 1 if it is a foreigner, 0 if it is Spanish. PC Skills has 4 categories: none, low, medium, and high. And then internet skills is also a different variable that is measuring how well a person can work with the internet in general, and in particular with specific tools of internet. And this is divided in categories: low, medium, high, and very high. The online opinion seeker is important in this particular case because looking for opinion makes you trust more in a particular vendor if it has good opinions. Then internet trust is similar to the previous one, but referred to the general internet, and it is also divided in low, medium, and high. And income has also several categories just to be able to measure how much income is affecting the decision of cross-border e-commerce. In this table in page 13, we have the estimations of the different models. And we see that not all the categories have significant effects. You see that, for instance, income has very little effect in this particular type of equations, and also that age has little effect also, and then education has little effect except for a European Union. So what we see is that several of the equations are telling us that many of the possible explanatory variables are not significant, while others are significant. So if we are a policymaker, what we want to do is look at the different cells that we want to look in this page and try to draw our own conclusions for this. So that will depend on the interest of different people who look at this. But it is important to know that not every possible relationship makes sense. This is a different picture of the one that we saw in the previous explanatory variables descriptions, and this is interesting if only because it's giving you quite a different result. You see, this is the rest of the table in which you find the effects. Most of them are null effects, but some others are important. For instance, if you look at the cross-border e-commerce in general, the one that is in the middle, the one in the middle right here, you see that male is significantly positive, and then in the case of age higher than 65, it is significantly negative in the sense that it has a negative effect on the probability of using cross-border e-commerce. It is similar to the case of very high education, which is master or PhD. This is well above 1. It is highly significant, and that is telling you that cross-border e-commerce is especially important and done by master's and PhD graduates. Again, PC skills is important. It is all the other ratios are above 1, as you see, and the last one is around 2, which is highly significant due to this Z coefficient, which is similar to the T coefficient. So the C is a statistic that is measuring the distance between the odds ratio that is measured, like a 160 in this case, 160 here, and 1, which is the no effect value. So in this particular case, we see that 160, 191, and 198 are significant, are above 1, and have therefore the PC skills has a strong and positive effect on buying cross-border e-commerce. The similar thing is true for internet skills, which is high and important for cross-border e-commerce, and that is the type of interpretation that I would like you to do maybe for the rest of the table, just telling me what are the effects that are measured significant and for how much, and also looking at the relationship with other variables that are clearly insignificant, like age, where I'm pointing here a cross-border e-commerce rest of the world. You see that all these values are insignificant. That is why they are omitted. They are omitted just to clarify that they are insignificant. And the same can be said in this transparency, in which the effects, for instance, the effects of income are essentially null, except for this category here, in which is 1.46, the cross-border e-commerce rest of the world, in which the category 2 of income, 900 through 1599, is significant. You see, these are the different statistics that are associated with the estimation. 0.14 is the constant, and the other constants are small again, but still significant. See the World chi-square test. This is a very important test because this is telling you whether the whole model is significant. So this is a joint test of the significance of each individual coefficient. So it is a joint test of the significance of all the coefficients. And this is highly significant because the chi-square of 20 is has a critical value which is maybe around 40 or 50, and that is way above the chi-square that has been computed here. And the pseudo R-squares here are small, but they are high in terms of the correctly classified observations in the model. Models sometimes show some doubts about their quality, and one of the reasons why is because usually authors don't give much explanation or much support to the results by using statistics that are useful to ascertain the quality of the estimation and the model. So the diagnostic statistics are very important. Here, they are especially important because a lot of people would say that we have high collinearity. High collinearity between the regressors is a bad idea and is a bad situation because it can lead to inefficient estimates and unstable estimates, numerically unstable estimates. So we have to check whether there is a collinearity or not. Here, in this particular case, it is difficult to do that because many of the variables are categorical, and category number 2, it does not mean that is twice as much as category number 1. Those are not cardinal values, they are ordinal values. So we know that 5 is after 4, but we don't know how much is the difference between 4 and 5. So that's why we use a version of the correlation, which is called polychoric correlations, and those are telling us that we have moderate correlation between the different explanatory variables. And this is something that you can do in Stata, and it is very easy to do, but you have to know exactly what you're doing to make sure that you understand what it is. So in general, the conclusion is that the models are good by many different estimation procedures and many different diagnostic tools. Now we are in section 4, conclusions, and let's see what we have learned from this analysis. We have learned one thing, and that is that things are more complicated than they look. Some of the variables are significant in one places and not in others. In particular, being a male is positively related to using cross-border e-commerce. Age is significant in cross-border e-commerce for those aged above 65, but not others. Education is positively related to cross-border e-commerce EU, while it seems mostly insignificant in other cases. PC skills is significant in most models, and internet skills is also mostly significant, especially in the high and very high levels. And trust on the internet seems to be relevant and positive for becoming a cross-border buyer, especially in the case of higher levels of trust. And online opinion seeker is relevant in some of the cases also. On the other hand, income seems mostly irrelevant. Foreign national is sometimes relevant, and in general, you would have to go through the different tables, looking exactly at what is the relationship for one market or the other. It is not something like in general everything is positive or negative, or there are some positive and negative variables. Let's look now at policy recommendations. If you want to foster the possibility of doing cross-border e-commerce, then there are some variables that cannot be manipulated. Most of them cannot be manipulated. But there are some specific ones like computer skills and internet trust, also online opinion seeker, that would admit some manipulation. So essentially we come always to the same idea that education may help. Education on computer skills and internet skills. And that is a big conclusion and supports the ideas of the European Commission that push for education in this type of markets. Caveats of this type of model is that some questions are not designed to ask specific questions treated in this particular paper, and that another limitation is that we would need to have panel data, which is something that we are going to do in the near future. The future research here goes always through the ideas of using a full panel data set, which now we have, and then going to the most modern and well-known different services like the used by children, health, e-government, cloud services, voice over IP, that may be more interesting for the general public than other better known services like the broadband or even mobile broadband. Okay, thank you very much for your attention. Bye.